This video contains the solution for the AP Calculus BC 2009 AP test, BC free response question number 4. So let's see, we have a differential equation dy dx is equal to 6x squared minus x squared y, and let y equal f of x be a particular solution. This is a derivative. The particular solution means after you've solved for plus c, for the c to this differential equation, and that we would need an initial point, and they're giving us that point here. So at some point that's going to allow us to solve for the c. First part, with no calculator. Use Euler's method with two steps of equal size starting at x equals -1 to approximate f of 0. So let's see if we can set up the chart for that. So Euler's method, we need x values, y values, so for part A. We need to know what dy dx is, which in this case I'll just write that in here so I know 6x squared minus x squared y, and then dy dx times delta x, that gives me dy, and then that's what I'll add back to the y values. So let's see, we're starting at -1, and -1, and they gave us the y value that goes with that, and that's 2. Plugging that in here, 6x -1 squared, that's 1, so 6 times 1 minus 2, so that would be 4. And delta x, well, let's make the rest of this table. They want 2 steps up to 0, so that's going to be -0.5 and then 0. So my delta x is 1/2. I'm getting bigger by 1/2. So 4 times delta x is 1/2. Gives me 2. That's how much y changed. So I come back here. It's like we've stepped along. This is all the information for a tangent line. We've stepped along that tangent line this far, and now we have a new point. So -0.5 squared is positive 1/4. So 6 over 4. That's 3/2. And then again, that's 1/4 times 4 minus 1, so that would be 1/2 times the 1/2, that's the delta x, which is 1/4. So that's the change in y, so it looks like that brings me to a y value of 4 1/4. And hopefully that is the correct answer. So 4 1/4, and this is the work that leads to my answer, so I don't need to show any more than that. For part B, at the point -1, 2, the value of the second derivative is -12. And they want me to find the second degree Taylor polynomial for f about -1. Well, let's see if I could do that. How do you make a Taylor polynomial? You actually find the value of the function at whatever value. This is at x equals -1, right? And then that means, since the value is -1, that means all my little factors are going to be x plus 1s. So that means plus f prime of -1 times x plus 1 to the first power plus f double prime of -1 times x plus 1 squared over 2 factorial. That's the second degree. All right, let's see, f of -1 is 2. F prime of -1, I'm going to have to use both coordinates. It's -1 and 2 plugged in here, so let's see. That would be 6 minus, oh, didn't we already do that? F prime, that was just this, right? So that's 4. We did calculate that before. So 4 times x minus 1. Oh, sorry, x plus 1. And the second derivative, they actually just told us the second derivative is -12. So that's -12 times x plus 1 squared over 2 factorial. You could leave it like that. You can simplify that to 6, but they would accept it just like that. And part C, Find the particular solution to the differential equation with that initial condition. So this is where we have to separate our variables. Dy dx is equal to, I'm going to factor out the x squared. Remember, we can only separate by multiplying and dividing. Adding and subtracting does not work. So factoring the x squared out gives me this, and then separating the variables, I get 1 over 6 minus y dy equals x squared dx. I take the antiderivative of both sides, and that gives me negative natural log absolute value 6 minus y equal to, the negative came from the little u substitution. It was just negative 1 in there, so that was an easy enough to do without writing out the substitution. Okay, and I want to solve this for y, so I'm going to move the negative to the other side. That gives me natural log 6 minus y is equal to minus x cubed over 3. The plus c, whatever that constant is, it can be positive or negative. We'll solve for it later, so I'm just going to leave it as plus c. And then exponentiate here. That gives me e to the natural log. That just gives me 6 minus y equal to e to the minus x cubed over 3. Remember that the plus c here, that's like if you have x to the 2 plus 3 from your algebra days, you know that that's the same as x squared times x cubed, right? So this would be like e to this times e to this, and e to the c is just like some other constant that I'm going to write out here in front. So again, solving for y, I move the y over to this side. That gives me y is equal to 6 minus c e to the minus x cubed over 3. And now we just have to solve for c. So what is our point? Our initial point is the point negative 1, 2. X is negative 1, y is 2. So when x, let's see, 2 equals 6 minus c e, x is negative 1, so that negative 1 and that negative sign, that'll be e to the 1/3. So let's see, if I move that to the other side and subtract the 2, c e to the 1/3 is equal to 4. So c is equal to 4 over e to the 1/3, or 4e to the negative 1/3. And that gives me an answer of y equals 6 minus 4. And then, since this is e to this something and this is e to this something, I could just bring this up as the same way that we combine these. I could bring this up there. That's 4e to the minus x cubed over 3 minus 1/3. You could leave the e to the negative 1/3 down here as part of that. It's the same thing. Any version of the correct answer is acceptable. But that's probably the neatest one. Not that neat, but that's it.